Hello and welcome. Today I'm going to teach you how to do a polished platform controller part 1, and we're going to do this in parts because it's going to be too large elsewise. So today, this is what we're going to have at the end of the whole project. It's something like this. So you can see we've got we can slide, we've got particles, we've got a double jump. We've also got Coyote time, so you can jump just as you leave the platform, so it stops you falling. It's a nice game feel. Same thing when you press A just before you land. You'll see I'm pressing it now and it just jumps just as it lands, which is what we want. We'll have a slide and a dash. So what we can do is get to part 1 and we're just going to handle the movement and some jumping. So let's close this down and we've got a little to-do list. So this is all what we're going to do in this tutorial. We're going to have the basic jump. We're going to have variable jumps. The longer you press A, the higher you go. Double jump, squash and stretch on land. Animations and its logic, Coyote time, which I spoke about, jump just as we land and check if we're hitting the ceiling. And let's go to, let me close this one down. And this is what we should have. So you'll notice straight away that this art is a little bit different. The reason for that is I don't have all the art for the, I don't own the art for the other one I've shown you, but this one is free and I'll provide a link to it in the description. So as you can see, we've got a double jump, we've got a Coyote time. If we hit the ceiling, and it just feels really nice. I've got a little slide. It doesn't look as good because we need to put particles in, but anyway, let's get into it. So what I want to do is move you over here. I'm going to open a new project. What we need to do is, as always, make a Node2D, call it main, and then save it here. Now you'll see you've got some folders already set up. We've got sprites here. Once again, these sprites will be in the link. Also, this project will be on GitHub as well if you want to do it that way. So what I'm going to do is we're just going to make like the floor. So I'm going to make static body. I'll just call this floor, and then we'll put that in here. Go to your transform, make sure it's at 0, 0. You'll notice that the floor's got this icon. It means it needs a collision body. So what we're going to do is add a collision shape, and we want to make sure this is a rectangle. Make sure the rectangle is, in fact, let's do snapping. So smart snapping's on. Use pixel snapping, configure your snap. I only use 1 pixel. It's just easier for my brain to cope with that. And this way I can make sure it is spot on there. Brilliant. Now what I'm going to do is I'm going to click here, and this will group all these objects together, so when I move them, it'll move them all as one. If I press S, I can now mess around with this. I'm just going to make it as about here, press Q, and then put it about here. What we want to do as well is I want to set up the project window, so we're going to go to the settings, we're going to go down to the display window, and what I want to do is make sure that it's right 640 by 360. Same again on here. Perfect, and then let's go down to the bottom. We'll make it 2D and we'll make it a keep width. Cool, you should be able to see now that it's much smaller, so let's just move that here. So what we want to do now is I want to save that. I'm going to make a new scene. We're going to other node, and this is going to be the player, so it's going to kinematic body. And then what we're going to do for the player is we're going to add in an animated sprite. And then we want new frames, click that. We're going to call this idle. And what we're going to do here is we're just going to go through each animation and put it in. I'll just do it quickly because it's going to take a really long time else. So I'm going to grab this, drag it in. You'll notice we've got one for double jump. Oh, why is that not capitalizing? There we go. I use caps to indicate that it's an animation. I'm going to make one called jump. Oh, actually, ignore that. We're going to have one called jump up, and we have one jump down. And on the jump down, I think it's this one, and then the jump up, it's the first one. Yes. So also idle, it's probably going really slow, so I'm going to say 15 for that. I'm going to say 10 for this. These are numbers that I already know, but you can fiddle around with them, see what you prefer. Now, you could have an animation of them falling down, like, you know, with their arms swaying or their coat wobbling or something, but I've not got the animation for that. But I would recommend doing that. It makes the game look much nicer. We're going to do the run now, so let's click this, run. In fact, let's do a turn as well. So you'll notice on turn is what I've done is I've just took this image and I've inverted it, so you might need to do that yourself manually. And for run, I'm going to drag this onto here, and then I think you want to be 10 as well. Let's see. Oh, let's play in. Oh, I've accidentally put in that one by mistake. You'll notice the turns there, so be careful with that. In fact, let me remove that. Make sure that's working. That's fine. That's fine. So what we're going to do is we want to have this on idle by default. That is getting pretty quick, but I don't mind that. Okay. So you'll probably notice that we need to put in a collision shape for the actual player. So what we're going to do is go to our collision shape. Same again, rectangle, and for this one I'm going to be a little bit more precise. So what I want to do is, yeah, I think so. We've got 1, 2, 3, 4, 1, 2, 3, 4. Yeah, fine. And then what I want to do as well is now I'm going to do the ground ray. So this is a little bit different than you probably learned how to do this before. I prefer this method, and it's you detect the ground using a Raycast, whereas most tutorials will say use the kinematic bodies is floor, but is floor is really a little bit janky and you have to mess around with it, and for me it's just too much effort, and this way works, I believe, nicer. So I'm going to do it this way. So I'm just going to put in a position thing here. Position 2D doesn't really mean anything. I'm just going to move it down at the bottom, and all this is going to do is Raycast container. So what we're going to have like 3 Raycasts, one for either side of the player, which is for the walls, and one beneath them, which is ground. But in this tutorial, we're just going to focus on the ground. So the walls will be for the next tutorial. So we want to add a Raycast to the Raycast container. Call this Ray ground, and then what I'm going to do is make sure enabled is true. The collision mask is free, and we're going to move that over. In fact, let's go back, go to your static body and make sure your collision is on layer 3 only. Now the reason we're doing this is that I don't want the floor ray to land on, say, spikes and it thinks the spikes are floors, right? I don't want that, so we're going to make sure that anything that's a floor, like your tile map, would be on collision layer 3. Let's go back, and what we're going to do is, we've got objects here, so it's a good time now to press Ctrl S. We're going to go to our objects, and we're going to cancel that, player, then save. Oh yeah, and also our Raycast looks a little bit wonky, we don't want that. So what we want to do is, if we want it to be 8, we want this to be 0, and I'm going to just use the mouse to do that. Now it's really important that your Raycasts from here to here matches this box perfectly. If I have it here, that means in theory that if there was a corner here, well, we don't know on the ground, and this will just kind of go through it. It'll look really weird, so make sure this matches up. And obviously don't have it there, you want it just underneath the player. I have it around about there, and that way it'll know once this touches the box, a floor, then we know that we're touching the floor. So what else do we want? And let's just put a camera in. Camera 2D. And we'll make sure this is the current camera, and yeah, the camera can just be there. Save that. We're going to go back to the main, and what we're going to do is click on main and drag it in the player. So I'm going to put the player there. Cool. We're going to save that, and then we're going to go to our script. Oh, no, we're not. We're going to attach a script to the player. And then I don't want it in here. Oh, make a new folder. Scripts and player. There we go. Create this. And what I'm going to do is, yeah, I'm going to use physics process. I don't think it really matters if we use physics or just normal process, but I know physics process relies on the physics system, which we know is going to execute 60 frames per second. That'll do it regardless of your monitor refresh rate. So if you've got a quicker monitor, it's not going to do it to the monitor's fresh rate. And the reason that is important, let's say if I'm on the 60 Hz, it will run 60 times a second on physics process. Whereas on processor it would run 6 times a second. However, at 122 megahertz, it's still going to run 60 in this process, but in the normal process, it'll be 120. Let's move this up. Let's get rid of this. I'm not sure if I need function just yet. So I'm just going to go through this and explain it as we go through. So what we're going to do is we're going to go to the top here, and I'm going to go. It's going to be a long one, so we're going to do some export vars. In fact, let me just copy this. I'm going to do it quite a lot. We're going to do our gravity equals. So I've put these numbers in because these numbers work for my project, but obviously, once again, you might want to mess around with yours. Acceleration equals 2000. The acceleration equals 2000. Direction equals 2000. Export from. Equals 2000. Oops. Horizontal speed equals 4. Have I done something wrong here? There we go. Weird. Max false speed. I mean, these variables kind of like self-explanatory, but I'll go over them as well. So obviously we don't want to fall faster than 100 pixels. Export that. Jump height equals 700. So this is the power of your jump. Export that. Double jump height equals 400. So obviously your double jump, so your second jump will be a little bit weaker than the first jump because you're doing it in the air. So we're going to have some export var squash speed equals 0.01. And then we're going to have our var. So we're going to have our vertical speed. Come on. Horizontal speed. I'm going to have touching ground bool equals false. Check if we're touching the ground. Touching wall bool equals false. Check if we're touching wall. We won't be doing that in this tutorial, but for the next one, var is jumping bool equals false. Check are we currently jumping. Same here. Is double jumping bool equals false. Check are we currently double jumping. Var jump. Check if we've pressed jump just before we land. Var Coyote time. I'm not sure if I'm spelling Coyote right, sorry if I'm not. check if we can jump just after we leave platform. So like Coyote, when he's chasing Roadrunner, he just leaves the platform and he's in the air and he looks around and he's like, hey, what's going on? And he falls. So that's what they call it, Coyote time. It's just a nice game feel. So when you leave a platform, you don't want to just, sometimes computers are really exact where your eye isn't. So a computer will just be like, right, you're off the platform, you're falling, but your eye might think, oh, you're still on the platform, that doesn't feel right. And then you start to blame the game, but really it's your eye. Lots of variables, bear with me. Var motion equals vector 2.0 var up. Yeah, so vector 2, and we want to 0 minus 1. So minus 1 on the y is up. It's inverted in programming. So we're going to pass the up variable into the direction of the kinematic body just to let it know which direction we class as up. And then we're going to go on ready var any equals animation sprite. On ready var ground array equals, let's find that ground array. Oh, come on. Second time lucky. So what we're doing is we're passing these variables. This one's going to contain our node of the animate sprite. This is going to contain our ground collider. Ground Raycast even. So what we're going to do here is, normally people use a state machine for this, and I probably would recommend that, but for me, I find there's less code if I don't use a state machine for this particular platform controller. Now, I would use a state machine on whether, hey, have I just died, am I alive, as the game just restarted, then that would probably use it, but I'm not going to use it for, hey, am I jumping, hey, am I idle. I just find that really convoluted for me personally. Let's go. So I'm going to say check if we're grounded, and we're going to put one here, check ground logic. Check if we're moving, jumping, sliding, etc. So we're going to say handle input delta. In fact, probably it's a bit bigger, a bit late now, but delta. Is that not right? Oh yeah, we haven't declared yet, but I will. And then apply the physics once we're done with the previous steps. So what we're going to do is say do 6 delta. So let's put these in. I'm going to say func check ground logic, func handle input var delta, func do physics var delta. Ooh, and don't forget this as well. I always forget that. Let's see if I can move this over there so I can see the code better, because I'm using a sample project to do this from. I can't remember this right from the top of my head. I know there is some coders that can, but I'm not that much of a genius. So we're going to go and check for Coyote time first. Time have we just left platform. And this is going to be if we're touching the ground and ground ray dot is colliding. So we're saying, hey, are we touching the ground currently, and is our ray now not colliding? It means we've just left the platform, right? So we're going to say touching the ground is false because we're no longer touching the ground, and we're going to say Coyote time equals true, so we know that. There we go. Now, this is going to be a little bit hard to explain because it's quite new to me, but we're going to use something called a yield. So I'm going to type the code out and try and explain it the best I can, but bear with me. Yield. If I can spell it right. So get tree. And then what we're going to do with this yield is we're going to create a timer. And this can be time. Ooh. How long will this timer take to execute? So we're going to say 2.2. And then it's going to be timeout. Brilliant. So what's going to happen here is this is going to run in our physics project. This is going to, if this is true, we're going to get, if we're falling off a platform, then we're going to say, right, we're no longer touching the ground. We're going to put Coyote time as true, and later on we'll say, hey, are we in Coyote time? You can still jump. Now, we don't want Coyote time to be true forever, do we? So I'm going to say, wait 200 milliseconds. And after 200 milliseconds, we want to say Coyote time equals false. The way we do it, the yield will pause this, will pause any code past this will be paused. So it's going to pause here. Pause here for 200 milliseconds. And once that's complete, then it'll roll over and we'll set Coyote time to equals false. Now, I would really recommend looking up tutorials on yield for GD script. It's a really great tool, and it will save you having to put loads of timer controls in if you know how to use it properly. My previous example, I was actually using a timer, but this is a much better way of doing it. So let's go back here. We're going to say check the moment we touch ground for the first time. And we'll say A, if we're not touching the ground and ground ray dot is colliding, then we know we've just landed, right? So we know that we're not classed as touching the ground, but our array is now touching the ground. So now we know we've just this moment landed on the ground. So we want to say any.scale equals vector 2, and we'll just put 1.2 and 0.8. So you might think, oh, well, that's a little bit strange. Why are you doing this? So the animation scale, what's going to happen is when we touch the ground, is on our X we're going to stretch it, and on our Y we're going to squash it. So when you land, we'll have this squashing kind of animation. I'll show you what I mean by that here. So watch the character when he lands. He squashes. See it? Squash, squash. And he stretches when he jumps. So we're setting it to be squashed. Later on we'll lerp the variables back to 1, which will basically push him to his normal size. So let's get carried on. And also what we want to do as well is I want to say set if we're touching ground or not, and we're going to say touching ground equals ground ray dot is collider. So this, if these states don't happen, then we'll definitely make sure that this will happen. So we'll always make sure that touching ground is true or false, and it'll always be accurate. So now we want to say if we are touching the ground, then we want to say is jumping is false. So we know we can't be jumping because we're touching the ground. Can double jump equals true. We know that that our double jump gets reset. So you don't want to keep double jumping in constantly. We want one double jump, and then we want to land, and then that means hey, we can double jump again. We want to make sure our motion dot y equals 0. because we're on the ground, we don't want to keep pushing downwards. We want to also then make sure our V speed is also 0. Can double jump is not declared. And we'll say check if we can double jump. I thought I did that. Maybe I missed it somewhere. Cool, okay. Alright, now what we want to do is we want to handle the physics. Do you want to handle the physics next? Yeah, let's do the physics next. And I'll do the input later. The input I think is going to be the input stuff is the longest stuff, so let's just do physics. So what we're going to do is we're going to say, hey, if is on ceiling, so that's the kinematic body method, and what I'll do is we'll check if something's directly above us. Now, this is less fiddly than it is on floor, so I don't mind using this, but you could use a raycast pointing upwards, but I don't think we need to for this one. And we're going to say motion.y equals 10 v speed equals 10. And you might be thinking, why don't you use 0? What would happen is you kind of, when you hit the top, you'd float a little bit before landing. And what I would like to do is just push you down a little bit, just sort of like, not like you've bounced, but just so you fall a little bit quicker. It just feels nicer. I can't really explain other than that. And what we're going to do is we're going to say v speed is constantly gravity, make sure I spelled gravity right, times delta, apply gravity downwards, v speed, oops, equals min v speed max fall speed. Cool. So this makes sure that we won't fall we won't fall quicker than the max fall speed. So limit how fast we can fall. Update our motion vector. Motion.y equals v speed. Motion.x equals h speed. Apply our motion vector to move and slide. Motion equals move and slide. And then we do the motion and we use up as, what does that variable say? Let's go down. So yeah, that's our up, what's our up direction, and we know that is y minus 1, so it's up. And then what we're going to do is we're going to lerp our squash squeeze stuff scale, and I'll apply squash squeeze, and we'll do that here. And then this would be any.scale.x equals lerp any.scale.x. We want it to lerp to 1, and we want it to do it at squash speed. What I'm going to do is copy this, and then we're just going to change this to y, this to y, and it'll do the same thing. So what's happening is this is always being called, and it's always trying to slowly push us to our natural size. So when we land, we'll squash, when we jump, we'll squeeze, but this will always be pushing us forward, and it'll lerp it so it's not like it's not linear, it's got like a nice smooth motion to it. Cool. Okay, so I'm gonna do the handle input. This one is a little bit lengthy, so check ground logic, we've done that. So what we want to do is we want to break this up, so I want to say handle movement delta and I'll do handle jumping delta. Let's put the funcs in. Cool. Okay, so what I didn't explain earlier is I did actually have this working for your control pad and for your keyboard. However, I did forget to do one thing. Why is this? Oh yeah, I don't forget that as well. Is we didn't put in the jump variable. What's it called? So it's project settings, input map. So we haven't put the jump input map. So what we're going to do is press jump, and then we're going to go to this key and we'll just use space as jump, and then what we're going to do is go back and we're going to go to joypad button, and it's A by default. I like A to be jump, I think that's the default one, so press that. So now we know that Xbox A, because I've got the Xbox One, it will be jump as well as spacebar. So what we're going to do here is controller right, keyboard right. What am I using? I am also using the arrow keys instead of A, D, so you could, in fact let's do that. No, I'm not going to do that for this tutorial, I'm just going to keep it as is. If import dot get joy axis, so I know that 0 is your left, sorry, 0 is your first device, which I know is 0, 0, and then the axis 0 is your left, which is my left analog. And I'm going to say, hey, is that more than 0.3? Or are we import.is action press? And that's right, UI right. So I'm going to say, hey, are we holding to the right of our left analog stick to the right, or are we currently pressing the right arrow key on the keyboard? Then I want to say if h speed is -1, -0, sorry. For this I want to go h speed plus equal deceleration times delta. If we're touching the ground, because we can still move left and right in the air, so this might not. So we want to make sure that we are touching the ground. Then I want to say ani.play turn. So we know that we're going to do the turn animation. Now, for me, I'm using one frame and it's inverted, so it just looks like he's skidding on the spot. And I like that. It works for this. Else, if h speed is less than our maximum horizontal speed, so we're going to apply the acceleration. Oh, that's not right. H speed plus equals acceleration times delta. And what else do I need? I want any dot flip h equals false. Why is that? Oh yeah. Also, another thing to do is we want to make sure that our animation is flipped when we're going to the left, so that'll be true, going to the left, and this is obviously going to the right, so it'll be false, meaning it'll go back to its original state, which is facing right by default. Then also I want to make sure that we touching the ground again. If we are, then we know that we should be running. Oh, I keep doing that. And then finally I'm going to say else. Else we've obviously hit the maximum speed. We want to do the same thing again, touching ground, and dot play dot run. Brilliant. Now I'm going to do the same thing again, but I think I can copy and paste this. Let me just check. Yeah, it looks like I can. So we're just going to copy this. We're going to go down. here, and then instead of, we're going to go else if, and this is going to be minus, and this is going to be left, and this is going to be more than 100, and this is going to be minus, this is going to be more than the minus, this is going to be minus again, this is going to be true, and I believe that's how it should be. And then finally I'm going to say we're not pressing left or right on any of the controls, so it's going to be else, and this is going to be if touching ground. So we're so we're touching the ground and we've just let go of our controls. We want to move our H speed so it slows down, and there's a nice little algorithm I'm going to be using. I can't really explain it that well, but it's how Sonic the Hedgehog actually, that's the way I got the algorithm from, does it slow down, but this is just adding a lot more friction, whereas Sonic the Hedgehog had a lot less friction. So what we're going to do is, instead of typing that out, I'm just going to copy paste it because it's quite complicated. So what we're going to do here is, that's really hard to explain, but sign means that if the H speed is more than 1, so say if H speed was 7, the sign would say it was 1, if it was minus 7 it would say it was minus 1, and if it was 0 it would say it was 0. And what we're doing here is we're decreasing this depending on which way out we're currently moving until eventually it's at 0. So that'll kind of like give us a nice little skid to stop. And then we want to do the handle jumping. Oops, I just realised I put that in the wrong place. Okay, so that's quite important. Yeah, okay, sorry about that, that was quite a bad one. So we want to do the handling jumping. So let's see what we've got here. Cool, let's go. So if Coyote time and input dot is action just pressed jump, we know that hey we've only just left the platform and Coyote time's still true, so we know that we can jump. So v speed equals our jump height, which is minus 700, so it's just going to push us upwards. And is jumping is obviously going to be true because we are jumping now, and can double jump equals true as well because we know we can double jump. And then I'm going to say if touching ground, if in input dot is action just, is it not, oh, jump, yep. If we just jump, or jump press, so that means that we're going to do this code later on, but if you press A just before you land, I want to treat it like, you know, just a few pixels before you actually touch the ground. You don't want it just to stop, because as I said before about your eye not catching up with the computer, so this will just make the game feel a lot nicer. So what we're going to do is, I'm going to do that, put these in the parentheses, and then I'm going to say and is jumping. Oops. We will get there in the end. So v speed equals jump height. It's jumping, so it's the same again as just before. Touching ground equals false because we just took off. and Annie.scale equals vector 2, and we want to squish this. So we squish the x and stretch the y. Else we're not touching the ground. This is where we can do our double jump because we know that we're not touching the ground. If the speed is less than 0 and we're not input dot is action pressed jump, and we're not double jumping, what we're going to do is we're going to set this v speed equals max v speed jump height divided by 2. So you might be thinking, hey, what's going on here? Now, this is going to be checking that, hey, are we going upwards, which is -0, and if we're not pressing jump, so if we're not holding down jump, so it's action pressed rather than is action just pressed, it's is action pressed, so is jump being held down and we're not double jumping, then we're going to limit the height jump. So this is our variable jump, so I probably shouldn't make a note of that. Variable jump logic. So this will, if we tap it, then we know that this will no longer be this will be false if we just tap it, so this will limit how far we jump up. If we hold it, it'll keep going up until we hit 0 and then come back down again. Let's go here. I'm going to say if can double jump and input dot is action just presses it. Yeah. And not Coyote time. I want to say v speed equals double jump, and we're going to play the double jump. Play. And I'm going to say, hey, we are double jumping. And then obviously we can no longer double jump because we've just double jumped. Brilliant. Do some animation logic on the jump. So let's do that here. So we're going to say if is double jumping and v speed is less than 0, so we're going upwards. Then we want to animate dot play jump up. So we know that, hey, we're not double jumping, but our current speed is going upwards. Then we're going to make it so our animation is jumping up. Obviously, if it is double jumping, we want to make the animation do its double jump, its somersault even. So we're going to say else if is double jumping and the speed is actually going down. Oops. Then it's going to be Annie play jump down. Else if we are double jumping, and Annie dot frame equals 3. So we're setting the double jump here, and obviously we're going to be double jumping. So this is going to be skipped until we get to here, and the animation frame 3 is the very last frame of the double jump. So now we know we're no longer to be double jumping because we've just finished the animation. We only want to do one somersault. So for that, we're going to say is double jumping equals false. And we're going to say check if we're pressing jump just before we land on a platform. So I'm going to say if import dot is action just press jump again. I'm going to say jump pressed equals true, and we're going to do the same as the Coyote time. We're going to pause. So we need to. So when we do pause, we're going to get a timer. So create a timer even. So we're going to get a tree. We're going to create that timer. We're going to say 0.2 again because I like that number. And then I'm going to say timeout because it has to be timeout because that's when the signal gets called. And then this is going to say air jump equals false. So what we're doing here is if we are in the air, so we say touching ground, else we're not touching ground, we're in the air. If we do press jump, then anytime we press jump, we're going to wait 200 milliseconds, and if we don't touch the platform by that time, then air press jump will be false. Else, if we do touch the platform in that time, it'll be true, so we know we're jumping straight away. So it gives this nice bounce straight away, rather than you press jump just before you land and it just sticks to the ground, which is a horrible feature. It's movement and movement. Is it? Have I not done idle on this? Oh my god, I didn't. That's really embarrassing. So what we're going to do is we're going to move this back, and I'm going to actually go here and go any.play idle. And we have got something going wrong there. When we jump down, oh, that's fine actually. We can do a jump. And can we jump off the platform? Yeah. So you'll notice, see, it's I know what this is. So we're going to go to our 2D. Now the reason with our stretch looks really weird is that our stretch point is happening in the middle, so you can imagine we're doing this where we want this. And to get around that is we want to go to our player, we want to go to animation sprite, and then can I just hide some stuff just so I can see where I'm going? There we go. Let's hide this as well. So you want to click the animation sprite and then press V, and I want it on his feet. Let's enable this back up, and then you'll notice when he lands now. There you go. And then when you just jump before you land, see it jumps. Perfect. So this concludes number 1. If you look at my to-do list, if you want to pause that, you can have a look. If you want to add anything to that, let me know in the description. This project will be up on GitHub, and as well as the link to the itch.io where you can find the art to this project. But I do recommend using the GitHub version because it has some custom stuff I've done myself. Anyway, if you made it to the end, congratulations. Sorry for our mistakes, but I'm a human, and I'll see you in the next one. Take care.